If you want your steam engine to have a crisp beat, something like the large-scale locos and something like this, well, then the design and manufacture of the port area is incredibly important. And that's what we're going to tackle in this video. Hey guys, I'm Luca. Welcome to my channel. So one thing you will see not so often in my builds is me using a ruler. And the reason is, when I was just a little guy in school, I failed using a ruler and marking out. Sorry, Mrs. Hesacker. I'm sure she's watching these videos. Ha ha ha. Actually, she's probably about 200 years old now. Easiest way to do it without using a ruler is, of course, a set square. And what we want to do is we want to mark out where the ports are relative to the cylinder bore on that face over there. Now, incidentally, there's two different ways of marking out on a casting. You can either buy marking out glue, which comes in a spray can, or you get a marker, and that works out relatively cheap. What I like to do is I just use a permanent marker. It just works just as well. In this case, I've shown both so you can see the difference. Now, the ports need to be centered to the bore. So what we're going to do is we're going to find the relative position to the center of the bore, and we're going to map it from one side to the other. And of course, not using rulers at all, because I hate using rulers. So now we have where the port needs to be on this face, and also this is where the port holes are going to be more or less over there. So let's do that to the other side. Notice how much easier this is than using a ruler. And also, when we tie it up on the valve face, you can see very, very quickly if you've made a mistake somewhere. Now we have 1, 2, 3, 4 lines, and what we're going to do is we're going to just check that it aligns with the set square. And there we go. That looks good. And that looks good. To find the center, I just stack it up like I've showed previously. And what you do is you just draw a line, you flip it around, and if those lines match up, you know you spot on center. That looks pretty good. To find the center line of the steam ports, it's again just adding another scrap bar and drawing a line. So then that's the center line of your exhaust port, and that's the two center lines of the steam ports. And they're all relative to the outer faces perfectly in the middle of the casting without using a single ruler. It is absolutely imperative that the vise is set up relative to your feet so that your valve ports are perfect relative to the reference face. Now your stationary part of your vise is what you're going to put your reference face up against. So that's the point of the vise that you're going to set for these operations. And it's actually really easy and quick to set up a vise. What you do is you pull the vise up against one side of the milling slot, and you tighten both studs. Then if you're lucky enough to have a DTR, you bring the DTR so that it goes to 0, and then you wipe the DTR from one side to the other side of the vise. Now my milling machine is relatively fixed, so that's pretty good. But if it was out, what you would typically do is you loosen the one side and you tap it until it is back on 0. And what you're looking for is typically about 10 micron from one side to the other. And that looks pretty good. So I'm happy with that. If you are not fortunate enough to have a DTR, you can use the touch and engage method. And all that you do is you put a piece of high-speed steel into the chuck. You just let it touch the fixed jaw. You note the reading on your dial gauges for your machine. You take it away and you bring it all the way to the other side of the vise. And you repeat that operation. You move it till it just touches the fixed jaw, and you note what's on your hand dial. Now you want both sides to be exactly the same. Let's just quickly talk about holding this casting, and there's a couple of tricks here. First of all, I'm holding it along the length of the cylinder, and the reason why I'm doing that is there's no chance that I'm going to crush the cylinder when clamping it in this direction. Cylinders are typically a lot stiffer in this direction, so that's perfect. And it has the added benefit of you clamping your fixed jaw on a reference surface. Also have a look that I'm using newspaper between the fixed jaws and the casting. That does two things. It holds the casting beautifully, but also it doesn't damage the machine face that we've just machined. So to get that nice crisp beat that each builder is looking for, one of the things you need to realize, other than designing the ports properly, is the ports need to open along the full length of a line, and it needs to open uniformly. If the valve opens at an angle, you tend to get a sort of a fizzing sound before the port opens, and you don't get a nice beat. Now this is always the piston side of my builds, and I always use that side as reference, and it's always against the fixed jaw, and that typically gets done for both cylinders. Now if the rod goes that side, the valve rod will also be above it, and if we line up that jaw relative to the piston in this direction as well as the valve rod, provided the valve is made properly, you know it's going to open perfectly along the full length, and this needs to happen for each valve port. Now in my video it looked like I was doing a CNC machining around the length of the port like this, and I was doing it blind because there were all the chips lying on top of the casting, so I had no idea what was going on. Believe it or not, I do not have a CNC machine, nor have I any intention of ever buying one. So how did I get that right if I was machining blind? Well, it's a little trick I learned. Most milling machines come out with these beautiful slots on the side of the machine, and you can put in nice stoppers to stop the direction, and typically that would be the direction over there. So that side is sorted, but what about this side? Most machines don't have that. Well, every one of my machines, I add a system to the side so that I can do exactly the same thing. That allows me to walk around this pot in one smooth operation, and each cut is perfectly on line with the previous one. Now you can actually see that there's no steps along the length here. So this turned out pretty good. So this is the first time I'm actually going to use a measuring instrument. Now that steam port, the exhaust steam port, needs to be more or less in the middle of the casting. So what I'm going to do is I'm going to measure from the side to the one side and the other side. Now I got 28.66, 28.6, 28.7, somewhere around there. So now what I'm going to start doing is I'm going to start shimming my stops until I get that size port exactly where I want it. And we're going to move from there. It's a bit of a fool's errand trying to bring up something against the surface that you don't want to mark. And we already have these nice stops. So if you want to open up the slot, it really is just a matter of bringing it up against the stop, loosening up that stop, and then I like to use these feeler gauges that you typically get in the automotive section. You just bring that stop up against that feeler gauge and you give it a bit of a tight. Then you know that you have opened up that slot by exactly the right amount, and you didn't need to bring your tool up against a surface that you don't want to mark. To measure the depth of this port, it's actually a good idea to make one of these little depth gauges, and that is spot on. So now what I'm going to do is I'm going to move this down, I'm going to zero it, and I'm going to lock the slide when I open up that port. A couple of additional points when doing these ports. Even though you do sometimes get ports that are, say for argument's sake, a 3.2mm width and a 1/8 milling cutter will be perfect, it is a fool's errand to use that milling cutter, because typically a 1/8 milling cutter will machine those slots to an oversized slot, and that's not what you want. So in this case it's a 3.2mm slot. I'm using a 3mm slot drill just because that was one of the last milling cutters that I actually sharpened. Typically what you do is you machine each slot using the stoppers that I showed, and then as you go you measure each important dimension. The width of the slots is important, and also the gap between the exhaust slot and the main steam slot. It is important to open the slots carefully as you go, and they're never machined size for size right from the beginning. In that way you can correct any errors that you typically find when machining sort of as you go. So we can't really go further with these cylinders at this point. And you might have noticed that each step in the machining process had a very specific goal. We did the bores and we made sure there was no casting inclusions. If there was, we made a plan with the sleeve, problem solved. Then we went on to these valve ports that needed to machine very, very accurately, and that worked out quite well. If there was any casting inclusion with these valve ports, then I would typically scrap the casting. You can fix that, but it's a bit of a mission, so rather just scrap the casting. If your valve ports are a little bit out, I would say about between 50 and 100 micron out, I could live with that. It would still be okay. You're not going to win any efficiency competitions, but you're still going to have fun with your little steam engine, which is what it's all about anyway. Most of the indiscretions on these valve ports can actually be corrected with the valve itself, and I'll show you when we get to the valve how to do that. But typically I wouldn't scrap a casting if it's a little bit out. One thing we cannot do at this point is we cannot drill the cross holes from the edge of the cylinder to the steam intakes, and there's a reason for that. The minute that you drill that, you deform this cylinder at the very end, and it becomes very, very difficult to check a piston fit. So before we carry on, before we do that, let's make those pistons. Let's make sure that that piston and cylinder fit is perfect, and then we know if we create a little bit of a bore and it gets stuck, we know that it's not the fit. We just need to deburr it a little bit in the fending area. Let's do those pistons. So typically there's two fundamental ways of making a piston rod assembly. The first one is a taper fit with a locking nut at the end, and that works fine, no issues. I personally don't like that way of doing it because look, you have a taper, something could go wrong, the nut could come out, it's just not as robust as I would like on my steam engines. What I found to have worked incredibly well with all of my steam engines is to use an old technique that a lot of the older designs sort of incorporated, and that is a combination of a screw thread pitch and a press fit. And if you tighten that very tight onto the press fit and you knock the ends of that thread, you know that that piston is not going to come off of the piston rod. And that's typically how I do all of my pistons. So the best way to get rid of tolerance stack up between the rod and the piston is to machine it as an assembly. And then you know that it's perfectly concentric and you won't have any sticking issues from one side of the cylinder to the other. So obviously you need to make your components. Typically you start with a piston rod, and that is really easy. It's got a couple of machining operations, forming operations, thread cutting operations. Easy peasy, went like this. Now that the rods are done, we need to do the pistons. Now I don't buy bronze because I'm not rich. So I cast all of my bronzes, and typically this is just a type of tin bronze. I try to use the risers from my castings generally, but I don't use the same riser for the same castings. So in other words, this is not the riser from the cylinder castings. I do try to use a slightly different mix from my pistons to my cylinders. The reason being is you don't really want to use perfectly identical materials rubbing up against each other. Bronze is quite forgiving, so you'll probably be okay if it's your first casting and you want to use the riser for your piston. Not an issue. There's some tricks to doing this. Now this riser that I'm using here has been cleaned, it's been fettled, it's been ground, and the surface is a standard grinded surface. That is not great to hold in a 3-jaw chuck. Typically you want a nice clean surface for all 3-jaw chucks to hold, and you want it to hold it along the full length of a line in 3 spots. If you don't have that, the tool is likely to bite into this material, it'll rip it out, and it will just misbehave, and it will be a flat-out disaster. So the pistons will be machined slightly oversized and then assembled to the rod, and then I can do one final finishing cut and I can test it to the cylinders itself. Let's get to that. While I was shooting that scene, I heard someone at the door, and it turned out it was my best friend looking for a little bit of attention. So it's highly unlikely that a chuck will give us the concentricity accuracy that we need to get this piston perfectly concentric to the piston rod. So most lathes come with a taper on the spindle, and that is far more accurate than a chuck. And a collet is a beautiful way to hold the piston rod accurately. So that's how we're going to do these pistons. Okay, so we've just machined the piston rod assembly, and each piston rod assembly is made to the specific cylinder. Now you saw me using high-speed steel. It is a sharp tool, and I don't take sort of more than about 20 micron cuts, 10-20 micron cuts when I get close to my size. If you don't use high-speed steel that's incredibly sharp, you are going to get tool chatter. So stick to the high-speed steel. It is really worthwhile using that when doing your finishing cuts. Now we are looking for an incredibly tight tolerance. It's a steam tight but mechanically loose fit. Now how do you measure that? Well, okay. Mechanically loose is really easy. The piston needs to move up and down the cylinder with no appreciable resistance. Easy enough. The steam tight is a little bit trickier, and there's a number of ways of doing that. The easiest way to do it is to just put the piston down the cylinder, put it up against the light, and what you don't want to see is you don't want to see any light shining between the piston and the cylinder itself. If you get that, that's probably about the lowest end of the spectrum that you're aiming for a good steam tight fit. I like to check my fits slightly differently, and there's two different ways that I check. The easiest way is to stick the cylinder up against the palm of your hand and create a nice seal with the palm. If the piston is at the bottom of the stroke, you shouldn't be able to pull that rod out. And I am genuinely trying now. In fact, I'm wilting the palm of my hand. If you pull the piston out to about halfway and you seal up again, and you pull vacuum on the air that's left in the cylinder, it should bounce back, which is exactly what it's doing. This is a really good steam fit. I'm happy with that. Here's another way that I like to show a good steam fit. What you do is you take your cylinder, you put it up against an uneven surface, preferably some other type of rubber or plastic so that you don't damage the end of your piston, and you just drop your piston in, and it should drop freely to the bottom. If you take that cylinder and you put it up on a piece of flat surface and you have a piece of newspaper underneath, then it should go down much slower. In fact, it should ooze down to the bottom. If it actually gets stuck somewhere along the route down to the bottom, that's not a bad outcome, because that means that you actually have an incredibly tight fit, and that's what you're aiming for. Now, you may think that this was a fluke, a once-in-a-lifetime fit for a cylinder and piston, and it's not repeatable. Well, no. If you use these techniques, you will get this fit every time. And I get this fit first time with all of my cylinders and pistons. Here's a couple of examples of the piston and cylinders I've done over the years. So it's only now that we've checked the fit of the piston in the bore that we can go further with the cylinder. And there's a good reason for that. If we start drilling the drain cocks through to your bore, you end up with a burr. How do you check your fit? You're going to hit that burr. Now that we know we have a good fit, any burr is easy to correct because we know where the problem is. And the same holds for the steam ports at the edge of the cylinders. So that's why I check it now and not after I've done all of these other operations. So this is something that a lot of steam engine enthusiasts tend to battle with, and they get very nervous when they need to drill these holes from the edge of the cylinder to the steam ports. Here's a couple of tricks. When I do my designs, I set these holes to the bottom of the steam port. If you break through the steam valve sliding surface at the top here, that's an absolute disaster. What you actually want to do is you want to be at the bottom of this hole, and even if you're further than the bottom of the plunge, it's actually fine, it won't make any difference. So these holes at the top here, I typically do tangent with the edge of the bore, so that means when I mill back this slot over here, there's a little bit of meat between the bore and these holes. So here's a couple of tricks. With a lot of the older designs, they don't give the angles of these holes. Now, I add that to all of my drawings, so it makes life a little bit easier, so you know what angle to set the drill. So that's one step sorted out. Other way of doing it, especially with the older designs, is just set up your drill to your first hole, and then you plunge it, and you map the edge of your steam to the side of your casting, and that gives you a very good indication of where you're going to break through. And you can see I'm way towards the bottom, far away from the steam port surface. So that's fine. You'll also notice that I've clamped the cylinder again along the length, so I'm not holding this in a vise because that's always a chance that you're going to crush the bore. Clamped it down on newspaper, so I'm not going to damage my machine surface. And what I normally do is I normally have a bar that I bolt to my milling table, and I just set it up with a set square, and then this cylinder gets butted up against that and then clapped down. Then I do 1, 2, 3, 4, and I change cylinders, 5, 6, 7, 8. So I do 8 holes at once with against the stop, and then I change my angle and I do the next 8. So this is a quick and easy milling or drilling operation. So if you remember to my previous video of this specific cylinder, so bad news. One of my castings has a whole lot of inclusions on the one side, and that's why I hate casting gunmetal. But look, I'll get to that later. Nah! Oh, I need a cup of coffee. I actually had to sleeve it because the bore had a whole lot of casting inclusions. So this was drilling, and it's going to be milling, but it was drilling through stainless steel, through the gunmetal to the port. And as you can see, there's no issue whatsoever with doing that. What you do need to do is you do need to spot each hole with the center drill before you drill it, so that you don't get any deviation as you drill your hole down. Another little trick is a lot of the drills tend to drop down towards the end when you're drilling, and there's a very good chance that the drill is going to damage the far side of the steam port. So what I do is I make a little piece of metal, or I bend a piece of metal like this. That goes at the bottom of the steam port, and then it just gets clamped in place like that. Then when that drill breaks through, it just hits the plate and you're not going to damage the steam port. So to finish off the steam ports for this cylinder, it really is just the exhaust port that needs to be drilled and tapped, and then the drain cocks that need to be drilled and tapped. Now I can give one tip here. Gunmetal is horrific when it comes to auto feeding. Now what happens is when you plunge your drill down into your workpiece, it grabs on and it pulls into the workpiece, and it typically just destroys the whole casting. Now that's really a bad outcome. To get around that, what I typically do is I just nip the spindle lock just so that there's enough friction so that that spindle lock is held in place and it won't drop down. Then you won't have any problem with auto feeding. The other way of doing it is to take the flute of the end of your drill and just make it a flat rake. Now, look, I don't have 2 sets of drills, and honestly, who can afford 2 sets of drills? So I don't like that method. If you just lock your spindle, just so that there's enough friction when you drop down so that it doesn't pull into the part, you'll be fine. So let's finish off this video with the last few operations.